Question 10g, we're given that P of t can be written like this, where a, b, c, and d are greater than 0, and we need to use our graph to find those values of a, b, c, and d. So I've got the sketch of our graph that we did earlier down here. So we'll work out a first. So a is the amplitude, and the amplitude is just the distance between a maximum point or a minimum point and the principal axis. So to work that out, it's just going to be our maximum point minus our minimum point and divide by 2. So working out a then, we're going to get a is going to equal, well, our maximum point was 4.76, that's our max value of P of t, minus our minimum point, which is negative 1.24, and we divide that by 2, and working that out, we're going to get 3. Okay, so I'll just write it as 3.00 because we want it to 3 significant figures, and we had rounded these earlier values to 3 significant figures. Okay, so that is A. Now we'll work out D. So D is actually just going to be our principal axis line. So to work that out, that's just going to be halfway between the distance of our maximum and our minimum point. So D then, well, that's going to equal 4.76 plus negative 1.24, and we'll divide that by 2, and that is going to equal 1.76. So that is D. Okay, so now we'll work out B, and we can remember that with B, that the period is equal to 2 pi over B. So that means B is going to be equal to 2 pi over the period, and we just need to work out the period from our graph. So we could look at the distance between 2 successive maximum points or 2 successive minimum points, but we'll just do it an easier way. We'll just look at our point here, which is 0, and we know at 0.01 that cuts the t-axis there, because p of 0.01 was also 0. So that means then our period is 0.01. So that means b then is going to equal to 2 pi over 0.01, which is equal to 200 pi. Okay, so now we'll find c, and we're going to use our graphing calculator to help us do this, because it is a relatively straightforward way of solving this problem. So when we have a sine graph, remember we start on the principal axis before going up to our first maximum point. So what I'll do then is I'll draw in our principal axis onto the sketch of the graph we've got here. So that line, that dotted line in red, that is our principal axis, and that is the line P of t equal to 1.76, which was our value for d. So we'd start the sine graph here, where I'm marking it in that magenta color, then we would go up to our first maximum, etc. So what we want to do then is we want to find, well, how much has this been shifted along? How much has it been shifted from this P of t axis there? So to do that, we'll bring up our graphing calculator and find where the line of P of t equal to 1.76 meets our graph. So we've got our graph of P of t here on the calculator. So we'll just add in our principal axis, which is P of t equal to 1.76. So adding that in, so we get that there. So that's that red line, that would be our principal axis, and we can see it cuts our graph of P of t here. So what we want to find then is how many units to the right has our graph P of t been shifted. Okay, so we'd start our sine graph right there on the principal axis and then go up and down and so on. So we'll work out the intersection of those two lines. So if we go to Analyze Graph, to Intersection, now we can see there there. So we've got that coordinate there. So that is when t is equal to 0.000998. So what we have to do then is just round that to 3 significant figures. So we're going to get 0.00100. So that means that's how many units to the right our graph has been shifted. So therefore C, we'll write that down. So therefore we're going to have C is equal to 0.00100 from our graph that we saw there. Okay, and that is question 10G.